Hi everyone. Our lesson for today is general solution of non-homogeneous differential equation. We're going to find the particular integral when capital X equals polynomial in X. The general form of a non-homogeneous linear differential equation with constant coefficients is here. Now, when the right side is a polynomial in X, the equation becomes like this. For the general solution, we say that y equals complementary function, that is the CF, plus particular integral, that is pi. We learned how to solve for CF. Now, let us solve for pi, or particular integral of capital X. And this time, x is polynomial in small x. The formula is here. The fraction 1 over f of d multiplied by capital X. That is the right side of the equation. In this case, in this denominator, we're going to put it in the form 1 plus or minus the p of d. This is how we're going to do it. We take the lowest power of d as common, then bring it to the numerator. Expand it using binomial theorem in ascending powers of d, as far as the result of an operation on x raised to n is 0, or up to the degree of capital X. Here are the common binomial expansions. The first one is the quantity 1 minus x, that is raised to negative 1, is equal to 1 plus x squared plus x cubed plus and so on. Next is the quantity 1 plus x raised to negative 1 equals 1 minus x plus x squared minus x cubed plus and so on. Another is the quantity 1 minus x raised to negative 2 equals 1 plus 2x plus 3x squared plus 4x cubed plus and so on. The last to consider is this 1 plus x, that is raised to negative 2 equals 1 minus 2x plus 3x squared minus 4x cubed plus and so on. Example 1. Solve the equation 2 times second derivative of y with respect to x plus 3 times dy over dx plus 4y equals x squared minus 2x. The general solution is y equals CF plus pi. Let us find CF. Using operators, we have now the quantity 2d squared plus 3d plus 4 that is multiplied to the variable y equals the right hand side values x squared minus 2x. The auxiliary equation now is 2m squared plus 3m plus 4 equals 0. Let us solve for m using quadratic formula. So we find the m to be equal to negative 3 over 4 plus or minus the square root of 23 over 4 times I. The values are one pair of complex roots, whereas the alpha equals negative 3/4 and the beta equals the square root of 23 over 4. So the formula for the CF is in here. Let us substitute the values of alpha and beta respectively. So we have this equation for our CF. Let us copy the CF somewhere here. Then let us find the pi of the right side x squared minus 2x. The formula is in here, then let us substitute the corresponding values. The f of d, that is the function with respect to the operator. So we have this 1 over 2d squared plus 3d plus 4, and the capital X, that is the same right-hand side values. So the next thing to do is to put the f of d, or the denominator, into the form 1 plus or minus the p of d. Look at our denominator here. The lowest value is the 4, so we will take this 4 as common. We're going to factor it out. The resulting expression will be like this. The 1 corresponds to this 4 that is divided by itself. 4 is taken as common, plus the remaining terms will be divided by 4. And we copy the x squared minus 2x. Now the expression inside the grouping symbol, we're going to bring it to the numerator. We're going to use a negative exponent. So it becomes like this. Next thing to do, we're going to expand the expression using the binomial theorem. Take note that this expression here is of this form. So by expanding now, it becomes like this. Take note that we stop up to the second power here, because the right hand side here is of degree 2 only. And then let us simplify further the expression. It becomes like this. 1 we copied here, minus, we split the numerators, and we have this 2d squared over 4 minus 3d over 4. Plus, when we split this fraction, we're going to copy only the 9d squared over 16. The remaining terms will have a degree that is more than 2, so we don't copy it. Then we have this x squared minus 2x. Next thing to do is to multiply this x squared minus 2x inside the terms of the grouping symbols. So we have like this. And then let us simplify the d squared and the d respectively of the terms x squared minus 2x. Remember that the d of x squared minus 2x means we're going to take the derivative of x squared minus 2x. And the answer is 2x minus 2. The d squared of the quantity x squared minus 2x means the second derivative of this function. And the answer is 2. Substituting the corresponding values in here, we have now this expression. And then let us simplify further some of the terms. This 2 times 2 over 4 will be 1, and the 9 times 2 over 16 is simplified into 9 over 8. Next thing to do, this constant 1/4 will be multiplied to each of the terms of the grouping symbol. So we have like this. Next thing to do is to simplify the fractions, and we will get this 8x squared minus 28x plus 13 all over 32. This is the value of our pi. It means for the final answer, we're going to combine the CF plus the pi. So y equals the CF value we write here plus the pi value is now in here. Example 2, solve the equation second derivative of y with respect to x plus 2 times dy over dx equals 1 plus x squared. The general solution is y equals CF plus pi. Let us use operators to write the equation. It is now the quantity d squared plus 2d multiplied by the variable y equals 1 plus x squared. The auxiliary equation now becomes m squared plus 2m equals 0. Let us solve for m. We factor out m, and that is m times the quantity m plus 2 equals 0. We equate each factors into 0. We have now m equals 0 and m plus 2 equals 0. So two values for m will be m1 equals 0, m sub 2 equals negative 2. So we have here two real and distinct roots. For the CF, this is our formula. Let us substitute the values of m sub 1 and m sub 2 respectively. So it becomes like this, and we can simplify this part, and the final value of CF will be c sub 1 plus c sub 2 times e raised to the negative 2x. Let us copy the CF somewhere here. Then let us find the pi of 1 plus x squared. We have this formula, 1 over f of d times the value 1 plus x squared. For the denominator, we use our function with respect to d, that is the d squared plus 2d. Looking at our denominator here, the smallest value is 2d. Let us factor this out, and it will show like this: 2d times the quantity 1, that is when we divide 2d by itself, plus the d squared divided by 2d. We simplify the d squared over 2d into d over 2. And from here, we're going to put it in the numerator using the negative exponent. So it becomes like this. Now, we want to expand this expression. Take note that this is of the form 1 plus x that is raised to negative 1. And this is the expansion. Using the expansion form, we have now this expression. We stop with the power 2 because the highest power of the right-hand side is only 2. Then let us simplify further. We have now this d squared over 4. For this 1 plus x squared, we will now multiply this to each of the terms inside the grouping symbol. So the expression now becomes like this. From here, let us simplify the value of this d with respect to 1 plus x squared and the d squared with respect to 1 plus x squared. Take note that the derivative or d of 1 plus x squared is 2x. The second derivative of 1 plus x squared equals 2. Let us substitute the corresponding values, and it becomes like this. We simplify further. This 2x over 2 becomes minus x, plus the 2 over 4 becomes 1/2. Also, let us show that this 1 over 2d is equal to 1/2 times 1 over d. Remember that this 1 over d is an inverse operator, which means this is an integral. Now let us simplify our terms inside the grouping symbol, and we will have like this: x squared minus x plus 3 over 2. We simply combine the 1 and the 1/2. Now let us show that this 1 over d is an integral. It becomes like this. Let us now take the integral of x squared minus x plus 3 over 2 with respect to dx. So we have now this x cubed over 3 minus x squared over 2 plus 3 over 2 times x. We can multiply this constant 1/2 inside the terms of the grouping symbol. And then we simplify it further, and we reach the final answer: 2x cubed minus 3x squared plus 3x over 12. This is the value of pi, which means for the final answer, We simply combined the CF and the value of PI. The CF value is here, plus the PI value we just copy here. I hope you learned something from this video. See you again next time.